Hello, everybody. Welcome to my talk. And I'm going to be talking about harnessing event-driven and multi-agentic architectures for complex workflows in generative AI system. And yeah, I know it's a mouthful, but and this is my second time, or actually more than second time, coming back to JDCon. So I'm very happy about that. And thank you again to Microsoft and to the entire Java team for the opportunity. So here's the agenda. And I will be quick. And essentially, too, I will a quick introduction of myself and also then talk about Gen AI. I know we're Java conference, but I feel that it probably will be helpful to have a bit of an introduction for Gen AI. And then I'll talk about event-driven world and AI and data. And then how do you apply event approach to RAG? This is for Gen AI types of pattern. And then also to the latest thing, which is like very hot now, is the agents and workflows area. And also, I will discuss too a bit about challenges of Gen AI and share with you some resources. So I'll begin. And who's Mary? As you can see, I won't spend too much time talking about it. Picture is worth 1,000 words. I'm currently at Calibrity, which is a consulting firm that's based in Cincinnati, Ohio, although I'm based in Chicago, and I'm the director of emerging technologies there, currently primarily working on the building up an AI machine learning practice, and also with my quite heavy hands-on Java development kind of background. It's really helping to do that. And also, too, these are just the different areas I'm involved with for high level wise for all the technology, as well as I'm a technology or technical community builder and organizer. I'm president of CJUG, Chicago Java Users Group, as well as the organizer of the Gen AI Collective in Chicago as well. Okay, so let me go straight into the brief background and introduction of generative AI. So if we kind of think about it, right now, I think perhaps this slide is old already. I kind of was still using it a month ago, but essentially too, as we can see, right, AI has infused into all fabrics of our lives. Not just are we consumers, it's like eating the cake, but then us too, as developers here, we are the ones that are building it. We are the producer of these capability in there. So like developers building AI applications, training models, all kinds. There are AI specific engineers, and prompt engineer too is more like an art, for example. So yeah, without getting all the details, we know what we have gotten ourselves into. But first, too, let's take a look at the high level wise how it fits in. On the left side is more highest level is the circle about AI being the all kind of self-containing onion right within it. But inside it too, that's the machine learning aspect. So of course, AI is dealing essentially with mimicking the intelligence of all kinds of living things, so to speak, right? And of also human behavior to do work. And then machine learning is essentially a technique by which computer will learn from the data itself without us humans to explicitly teaching it. So you're supplying it data and let the machine learn on its own and learn, there are also supervised, unsupervised trainings, or also like reinforcement learning. These are kind of the major area. But without actually much deeper is the deep learning layer, which is dealing with like neural networks. And essentially that's a lot more research and most difficult layer in which, we're having the techniques to perform machine learning inspired by our brain's own network of neurons too. So that's actually where all the generative AI is happening. So on the right-hand side, as you can see, AI, and then if you go deeper, right, the NN stands for neural network, that layer, that's where all of the large language models are, deep learning. And then as you can see, Gen AI is a specific area of LLM. And also Gen AI too is specifically work closely too with NLP, which is natural language processing. So that's where we're kind of venturing into today. Okay, so fascinating look at this Gen AI era, right? So again, what is Gen AI? Is disruptive, in itself and has the potential to change the way it's already changing how we create content and consume content. And I think, as such too, when it first came out, it was earth shattering. It seems like everybody was running to it. As we work more and more on it, we realize too there's also the limitations on it too. But certainly too, it was earth like a big milestone, because for the first time too, I think the difference also I have to point out is that Gen AI, for example, if we compare, people might be saying that, okay, well, Siri was already doing that voice recognition thing. But the Gen AI is that now we can actually use natural language processing as prompts to ask the robot, right, the bot behind the scenes to do all the work. And as such, too, I wanted to point out Gen AI deals more with the creative side of things. It can generate code, write an article, designing a dress, as the potential is limitless too, as opposed to predictive AI, which tends to be more working with, also the machine learning models, but it also rely a lot on like statistics, for example, to look at trends and then make predictions based on those data. So that's kind of a bit of a difference. And then, of course, all of the large language models, generative models, and also small language models as well. As we all know, they're more specific SLMs, LLMs, and these are the ones, just a small handful of the most popular ones right now. Is actually there are also even more, but of course, OpenAI is first and foremost the ones, and GPT 4.0, the 4.0 mini. As such, everything is changing so fast. It's really quite amazing these days. And I won't again get into all the details too, but as you can see, all of these, I'm just kind of sharing a handful of them. And also too, I will talk in a couple slides down also about the different modal aspect of these models too. And then of course too, all of the models are there, but without apps to make use of them, and that's what is called AI inferencing, is to leverage on these models and build and apply all of these, kind of use cases to build based on all of these model usages. Without the apps, I should say, is that it's not doing us any good. But as such, these are, also like a tiny percentage of what's out there right now, but there are actually much more too. And as developers, I'm sure a lot of us have worked with, not maybe not a lot of us, but at least some of us, right? We're using Copilot, for example, to help us, to guide us with our day-to-day coding work. And again, that's just only one model, but there are also plenty of other, tools and models out there that are also recognizing computer programming too. So here we go. This is the slides that we were talking about, the multimodality of these models too. First, it came out with more text to text, right? And essentially ChatGPT 3.5, sorry. And came out so text to text. And then very soon too, of course, there's Dolly. I pointed out too, is more image. In fact, the very first image to text and text to image model, Stable Diffusion, that came out, and it's really the first one that inspired like Dolly and the other image types of model to do things. And then, of course, there are also the code generation over here, like with Copilot, and then audio like Whisper, and also like video, like for example Sora from OpenAI. That's also a pretty amazing thing, that you can just by text describe a scenario, it will generate you the video. Or likewise, maybe from a video you wanted to describe what's going on too. Those are all kind of happening right now. And as such too, we look at all of these models. The way I look at it is that LLMs are very powerful, no doubt. It's humongous, and it takes a lot of energy to produce. However, if you kind of think about it, right, LLMs, eats in a lot of information, but it actually doesn't have memory of its own. Think of it as more like a runtime. In JVM, I think of the JVM world, I think of LLM is like the JVM for AI, Gen AI types of application. And that's kind of the runtime. Although LLM is limited because it doesn't have memory, it doesn't have that aspect of it managing memory. It has to rely on some framework to help it to do all of these things. And also the results too are probabilistic. As such, it's non-deterministic. A lot of things are based on fuzzy logic, so it's not very kind of like definite. So if you ask the same questions to the model itself, if you say you interact with it between different prompts, it cannot remember anything, and it comes back with different results as well. And also, too, the results are also opaque, so to speak. You cannot add attribution to its answers, too. And not to mention, too, the cost is still quite expensive. It takes up a lot of energy, especially if you kind of hear about data center. They are actually needing a lot of power to process all of these generative AI types of applications. Although I have to say, a lot of the chip manufacturers are, for example, like NVIDIA, that produce like GPU chips, all of these related technology, they are improving too. But I think it's still got quite a ways to kind of make it fully very efficient, so to speak. And also too, if you kind of look at it too, by itself, LLM without any kind of helper, right? Like let's say a library to help it, such as LangChain4j in the Java world, or Spring AI, then it's pretty much a one-shot usages. Again, it doesn't know how to retain any memory in between different asks, right? So it's like zero shot or one shot type of usages. Now, in order for it to become even more useful, is basically you have to think of real life examples that, for example, like an application such as airline booking system and order entry system. You also have to handle scalability issues, complex tasks, and as such, workflows. Data is not just in one state. Is going to go through, so to speak, a pipeline of different systems, and the data will get transformed as it travels down this whole multi-step workflow. So LLM doesn't have all of these things built in. And of course, again, I talk about the memory. It doesn't have any state information. So, with that in mind, let's also kind of take a look too. I think I wanted to talk about GPT. Again, GPT is essentially a transformer, and it takes simple prompts, and also it is essentially too, it transforms things, right? And it's basically answers questions like ChatGPT, answers questions for the prompts, and then it produces results. It basically then the transformer is like interacting with the LLM and comes back with the results that you're looking for, like writing a blog post and writing a computer program, all of these things. So, and also then it heavily employs the technique of NLP. In fact, that's what is really kind of essential, crucial in this technology space, because it's essentially then knows how to process languages as in its spoken form. And so as such, right, NLP is an interdisciplinary subfield of linguistics of computer science. It's pretty much, using probabilistic machine learning approaches as well. And so without going all the details, I'll just quickly go through. And LLMs, and we already kind of know it very well now, is a type of machine learning, deep learning kind of model, foundation type of model trained on a broad set of data, providing general purpose usages. And I already also talked about how it costs a lot of money, takes a lot of GPUs to process all of these things, and humongous number of parameters that it needs to be kind of processing as well. So again, let's kind of take a look quickly to LLMs. How does it fit within this model? Is, as you can see, is the transformers that fits deep inside the deep learning layer of the whole kind of AI ecosystem too. Okay, so now let's get into so much to talk about. Let's get into the event-driven side, right? This is the talk to is harnessing this event-driven way of doing things. Now, at the heart of AI, as I kind of already kind of passed through, is that we are dealing with data. So without data, it's basically, and not just the data itself, but also the flow of the data in many directions, right? This is at the heart of AI. That's what makes things possible. But as we all know, let's step back a little bit, understand data. And especially if you are less familiar with data, it's always good to be aware of that on the architecture level, there's event-driven architecture that can manage data. Of course, event-driven way isn't the only way, but I think we are more used to, especially in enterprise apps, in the old times are more the batch processing type. But the thing is with event-driven style is that it basically improves like performance in general. And also because of the nature of this architecture, it allows for real-time kind of processing. Now, try to also understand data too. It's basically data has different states too. And one is basically at rest. So it's basically data is being stored inside databases or file system or some kind of storage is at rest. That's the state. And it also can be called in transit too, is in when it is traveling from, let's say, you're sending data from one point A to point B, or from a program that's running on a cloud server to send it back to the storage and it's in transit, or it can be in use as well, meaning that it's transforming as it is, being extracted and you're trying to process it too. So these are different states of data. So again, the techniques too that actually gets into working with it will be event streaming or event messaging, or even a newer technique called event sourcing and CQRS, the command query responsibility segregation too. Now, I won't have time to get into all of these, but the thing is too, with event-driven, to me, I feel it would be, in fact, not just for AI, but for a lot of distributed applications, and that would be the backbone of making that possible for the future to handle the volumes, the scalability, concurrency, everything too. Okay, so in the case of generative AI streaming usages, right? So as we can see, I was thinking through some of these just kind of high level. Basically, Gen AI app input, right? You can have prompts that comes in from the command line or from the browser or from some mobile apps or some desktop app or all kinds of things that can come in, prompts coming in, and it needs to get to the destination, the component that manages these input. And then there are intermediary steps, right? So let's say in a RAG type of operations too, you can have different sources like database or file system or even like a socket coming down, network. For example, I used to work for like trading firms in Chicago, and they're actually, they call price, the ones that kind of publish prices for the trading prices, the price maker. So those things, they're sending data, raw data down socket. So that can also be a source of data, message queues or Kafka topic or some kind of event kind of topics too. And it sends requests to the LLMs. But of course, there are also many steps in between before you get to the LLMs too. And then from the LLM side, when it, get a request, it looks for the answer and then it sends back results from the LLMs too. So these are kind of streaming usages that we can identify. Now, I kind of also then look into these benefits of the event-driven approach. It handles the dynamic nature of data and its flow patterns too. And also it enables asynchronous style of processing via event streams. And it also enables like scalability, flexibility, independent, because the thing is, we're talking about decoupled type of processing. Data is from point A to point B, and then once it gets there, it doesn't get attached to any, so to speak, any kind of components. The data travels in itself, and you have the mechanism to move these data around. So it's very flexible. And also, too, like with different, let's say in the Gen AI, that's what I'm kind of envisioning is we can have different AI models and services. So let's say, right, I have an application of Gen AI types that essentially, too, there are certain models that are good for doing certain things. As I talk about, there are different modality. For example, like you can have model a mode, an LLM that's specific for images. The other is for videos and all of these things. And essentially, too, in all applications, right? There's nothing like only one, like a monolithic thing. It's always like you have data that's in the form of text or in images or videos or in code. They all need to be talking to one another. So we're now talking about essentially too, having an event-driven approach helps it because you can then isolate all of these components. I can have an agent that's only work with an image, that image strong type of LLM such as like Dolly, and it's doing its thing, but it's also interacting with another model that's better for working with video, for example, something like that. So for an event-driven approach, it actually is kind of the more ideal way of managing the different agents, how they communicate with one another. But at the same time too, even though, okay, all the benefits there, but be aware that there are also challenges, such as they are more difficult to debug, and it's harder to track the flow of calls and the data they carry. So essentially, too, when we design systems like that, we have to think ahead of time. What are the data like, and how do they go through different stages, and how do we design the applications? That's actually quite important too. And not to also forget, there are also observability side that needs a lot of work to manage these systems. Okay, so I spoke about RAG a little bit. So let's also step back a little bit for those of you maybe newer to this concept. So just really quickly, too, RAG is essentially a hybrid framework that integrates two components of the RAG model. And RAG, by the way, stands for Retrieval-augmented generation. And so as such, too, going back to LLM is pretty limited because it's trained on some set of data that you perhaps, for example, when ChatGPT 3.5 first came out in 2022, the data that it was trained on initially was only up to 2021 because it takes a long time to train it. So you take the data, let's say 6 months ago, and then it maybe takes 5 or 6 months to train it. So that's why your data is not the most up to date. Then what do you handle it, right? If there are specific up-to-date data, then you need some techniques to kind of essentially supply the data to work with the LLM to augment it. So essentially, too, there's this retrieval model to kind of help with bringing in data into the system. As I mentioned, it can be from database, from a socket, from a message queues, and from a file system, you name it, right? All kinds of data sources. And then after you retrieve it, right, and all of the data, you have to massage it, the data, maybe create a new prompt or modify your prompt to kind of make it more catered for what you're looking for. And then with that updated prompt, then you can send the request over to the LLM. And then when the LLM comes back with, then it's basically the generative AI, generative model side that is the RAG, this RAG generative model. It will then take the results and essentially beautify it, so to speak, enhance it, add more proper context to it, and then sends it back to the sender of this request, right? So essentially, that's what it is too. So essentially too, kind of look at it. Retrieval model is like a specialized librarian. It pulls in relevant information from a database or a corpus of documents, and then it fed into the generative model, and then that acts as the writer and crafting up coherent and informative text based on the retrieved data. So these two kind of models work in tandem with one another. That's what the RAG system is, and this one is just another extended description of this generative model. So it's in principle, it's not way too complicated, but it can definitely be making use of a lot of event-driven type of techniques to it as well. Now, then the next thing we want to look into is basically in the generative AI world is agents and workflows. So I like to propose, right? We can kind of consider using more of this event-driven approach to handle these. But first, let's take a look too at agents and agentic. So agents is one who is authorized to act for or in the place of another. It's like a computer application that's designed to automate certain tasks. Now, bear in mind too, as a lot of us are developers, it's not just restricted to Java, but it's all kinds of computer systems. In fact, agents exist, way before the current period of time, and it's essentially too, you can have it. They are also can be expressed in the form of functions, right? So it's much like a specific agent can be thought of translated into computing terms like a function or method to handle certain types of specialized tasks. So in the real world too, agents, for example, it can be a spy, that's kind of a spying for some political reason. That's an agent, insurance agent, right? All of these things is basically acts on behalf of somebody else. So likewise, it gets applied to this generative AI context. Now, Agentic is basically we refer to someone or something capable of achieving outcomes independently. So kind of agentic describe the nature of these agents, what they do. And so it's especially useful in AI too, because in AI as such, we know there are so many things that are happening. You can have different AI agents acting independently. So the key in here is that it will be autonomous too. It's autonomous because there's no need for you to explicitly tell it what to do. Now, the thing is, there's still, given the today's model too, is not true AGI, which is artificial general intelligence that knows how to reason things enough. So right now too, it still requires human in the loop, right? The agents can be doing some things, but the human will come in and supplement and make sure it's working correctly too. So that's another thing. So agentic is what it is. Now, the note too about multi-agentic. What is happening is that we live in a complicated world. There are many things, many agents operating. So we need some ways to kind of tie together all of the agents within a particular ecosystem, let's say. So that's a multi-agentic system, and that's what we're looking at. But as such, too, it is not an easy thing to do. Just think of human beings, too. If we need, human, like is running a corporation, you can have, an insurance company, you have insurance agents that are talking to different customers, handling all of their requests and things like that. Likewise, too, think of agents in the AI world. It's like that, too. But to me, though, not to worry, it's not going to take our jobs away. We still need a lot of human in the loop to actually make sure things gets completed, correctly. And that's the thing. Anyway, so going back to this Gen AI agents. So within the software context, these are software entities that can orchestrate complex workflows in a multi-agentic setting or coordinate the activities of multiple agents, right? And process logic, evaluate answers. You can have independent agent, you can have orchestrative agent, all kinds too. So anything you can name. So here too is the multi-agentic systems, which I have already kind of described. It's essentially multiple autonomous agents working together. You have maybe one or some kind of responsible higher level agents that tie together the whole thing, making sure they get orchestrated correctly. It's like an orchestra playing music. You have a conductor that makes sure all the instruments are playing together well and the timing is correct. So then the music comes out correctly, kind of like that. So okay, so fundamental building blocks, right? Within Java context, right? Leveraging on LangChain 4J, which is a popular Java LLM library. So you can have actually an AI services that's more flexible than the old chains concept in LangChain too. LangChain also is another very popular, is a primarily Python and also TypeScript, JavaScript framework. Upon which LangChain 4J also kind of adopted as a concept too. So anyway, there are AI services in here that actually more flexible than the old chains concept. It's essentially using a declarative interface to the desired API underneath and like Fire an object to and a proxy to. That's what it is. So now one thing I wanted to also kind of share with you is the multi-context protocol. Actually, I kind of got it all wrong. It should be model context protocol. And I apologize for that. It's originated by Anthropic. I wanted to point out it's still a relatively new protocol that just came out in late 2024, so just like 3 months ago or so, by Anthropic. And it's an open protocol. Think of it as standardizes how applications provide context to the LLMs. And then essentially, too, if you go to their website, it's basically describing an MCP protocol, much like your computer, or not just computer, any kind of devices with a USB-C interface or any kind of USB USC interface. So then with this interface, it basically defines how a device, through all the connector, which are all the cable stuff, they can talk to one another. So that's what it is, the standardization. So I see a lot of potential opportunities in there to kind of develop MCP compliant server or client that, essentially enable all of these agents to operate based on their protocol too. So, okay, so this one, let me kind of really quickly step through now, is essentially to combining EDA, event-driven architecture, and multi-agent for Gen AI too. So as you can see, right, that you can use events to coordinate agent activities. Event streams can enable asynchronous agent communications, and event-driven workflow orchestrate multiple steps generation too. So as you can see, there can be event bus that manage the event stream, API gateways that handles external events, and agents are autonomous components with specific capabilities. The agents will interact with the LLM, and it knows what to do when it gets the answer. It knows how to identify opportunities and communicate with another agent that's taking care of something else that it doesn't know how to do. That will be ideal, right? Okay, let me kind of keep going. Here we go. And there are event types too. There are many kind of event types that we need to deal with too, right? There are agent types, coordinator that decomposes tasks, assigns to agents, generator that produces content using AI models, evaluator can be assesses quality and relevance of generated content, and refiner improves and iterates on initial outputs, for example. Now, this is just a diagram I took from the AutoGen, which is a Microsoft open source generative agent SDK framework. And I've shared this link with you. So if you want to take a look too into some kind of suggestions of how it can be, right? An agent customization that you have helps with different conversation patterns, and also some example agent chat. For example, over here, the example in here is also showing that you can also allow for human in the loop in that kind of conversation. Just because right now the agents too isn't quite mature yet, so therefore you're still needing human in the loop. Now, the agentic design patterns too, I won't kind of get into all the details, but just want to point out it can be used for reflection and tool use or planning and multi-agent collaboration too. So these two I basically took from Dr. Andrew Ng, who's a well-known figure in the AI machine learning world. He heads out the deep learning.ai learning, and also the AI fund company, investing in companies too. So essentially, he's basically saying there's reflection in agentic approach. Essentially, to what you're doing is that you have an agents being able to reflect on itself and improve on the different iterations as it is interacting with LLM. So you basically want to have an agent that knows how to interact with LLM, and being able to take the results and go back to the LLM and tell the LLM to keep refining it. Kind of, that's a reflection approach. So that's kind of pretty cool too. And there's also tool use, because some ways or some cases in which an LLM doesn't have answers or doesn't know what to do, then you also want to prompt the agent and give it some hint and say that, well, go out to Wikipedia if you cannot find any answers. And so you're also helping the agents, providing help to the agents. And it's called tool use, because you're using some external tool to tell the agent what to do in case they don't have answer. And then there's also, this one is from another popular AI or Gen AI agent framework called Crew AI. It also is like describing this too. So I have also shared with you the GitHub link in here, and how it can basically have different agents and interacting with the process. And then essentially to Crew AI is a very much of a role-based type of approach. And rather than, it's not so much a low level type of infrastructure thing, it's more like abstracted layer where people can know certain steps, what roles they can define, and then you can basically have the Crew AI, the framework, knows how to build upon this too. So that's a very interesting framework, I'd say. And then there's also planning. That's another one, is basically letting the agent figure out how to solve the problem. You don't give it any hints. You basically tell it, I want to be able to, let's say a boy reading a book, or actually a girl reading a book, and then you have let the agent figure out all of the steps it needs to figure out, interact with different models and figure out everything, and generate you the final images. In this case, you're saying that I want a girl reading a book, so giving it a boy riding a bicycle, or I'm sorry, not a bicycle. Here is like a skateboard, right? Or some kind of skateboard. Okay, so that's that. And then also this most fascinating at this point is the multi-agentic collaboration, as I mentioned, right? Agents are being used in many complex, let's say this particular case is like an IT project kind of a project with employs different people doing design, doing coding, doing testing, doing documenting, and then you also have an agent, an overall like a project manager that manages all of the communications in between. Now, this particular link in here too is really an experimental research project that actually is also over here too. So if you're interested, you can take a look at that link and can get more information. I think it's even though it's kind of on a research level, but I think it points to what the future may look like, right? Based on how they construct this game situation. Okay, so examples of a few multi-agentic libraries. As I mentioned, AutoGen from Microsoft is open source. CrewAI is another quite popular framework now. And then also LangGraph too from LangChain. They are based on graph theory. And then also on the Java side, that's really exciting is Quarkus and LangChain 4J. It has a CDI kind of interface too, and I provide you with a link in here as well. Okay, so now coming to the end, I know I'm kind of running out of time, but challenges too. As such, we can see too, that was a very quick run through introducing to you how we can kind of think of event-driven, bringing that event-driven kind of approach to building multi-agentic architecture for complex workflow, but also be mindful that these are very complex system design and coordination, and you need to ensure consistency across like distributed agents too. And how do you handle failures and partial results? And then you also want to optimize it for latency and resource usages too. Anytime, especially you deal with network type of applications, there are always the latency part you need to worry about too. And of course, sustainability issues. It's very energy intensive at this point, is an energy hog, and is eco unfriendly at this point, I'd say. And of course, too, the Gen AI is still kind of facing a lot of hallucinations. When it doesn't have the answer, it could come back to you with answers that are not desirable. It cannot tell right from wrong. It doesn't have any moral judgment. You need to build in a lot of guardrails too. And so those are the kind of things we need to be aware of. So, and here, before I end, share with you some resources too. This slide deck can be accessed here with this bit.ly link and the QR code. And then also some information. I talk about the paper on archive with the next-gen LLM apps with the multi-agent conversations, the different libraries, AutoGen, LangGraph, and CrewAI, as well as the model context protocol from Anthropic. And also I have an article that I wrote for the Java Advent Calendar in 2024. I explore event streaming and multi-agentic approach for Gen AI workflows. So I kind of have a couple of more coding examples in there if you want to take a look. And with that, just wanted to share with you too also my stream and my Elusive AI podcast, which I wish to revive it pretty soon, and my Twitch handle. If you want to follow me, then you'll be notified when I'm doing an episode. And with that, I want to thank you very much. And this is how you can get a hold of me. I hope you can reach out. I like to have more conversations and see where your journey is. And thank you so much again to Microsoft and to JDConf. And yeah, thank you.